The Materials Recovery Facility, or MRF, has been the heart of the district's recycling operation since 1996. In those first 22 years of operation, the original MRF diverted more than 1.6 million tons of construction debris and reusable materials from landfill disposal. In 2017, the district spent $24 million and embarked on a year-long construction project to rebuild the 100,000 square foot facility with state-of-the-art recycling equipment designed and installed by Bulk Handling Systems. The MRF 2.0 opened in February 2018 and dramatically expands the district's recycling capacity. With the California goal to recycle 75% by 2020, the new facility will help the community we serve reach that goal and continue our tradition of being a leader in the recycling industry. MRF 2.0 processes single-stream mixed recycling collected from households and businesses from most of Monterey County. An additional sorting line is dedicated to recycling waste from construction and demolition projects. The MRF's purpose is to separate mixed recyclables into commodity types, like cardboard, mixed paper, metal, and plastics, so they're ready to be shipped off and manufactured into new products. The single-stream system uses 4 primary technologies to process and separate recyclables: by size, by density, by shape, and finally with high-tech optical and magnetic sorting. It can process 30 tons of mixed recyclables an hour, the equivalent of the material collected in 4 recycling trucks. Incoming loads are dumped onto the tip floor, where a loader scoops them up and drops the recyclables into a large in-feed hopper. This is the start of their journey along a series of 85 conveyor belts. Separation begins as recyclables pass over a large green primary sizing screen with discs spaced 12 inches apart. Large materials like cardboard are diverted to one conveyor, while the smaller recyclables fall through the screen to travel along a second belt. The recyclables flow past the pre-sort deck, where employees remove contaminants like plastic bags and textiles. Large pieces of cardboard and scrap metal are dropped into bunkers below, where they can be delivered straight to the baler. A recent study of recyclables delivered to the district found that the most common contaminants, plastic bags, food residue, greasy pizza boxes, coffee cups, and clothing, represent nearly 20% of the recycling tonnage. Removing these materials is expensive, but if they are not removed, they lower the value of other recyclables. Contaminants also create jams in the equipment, as they can get caught in the machines, requiring frequent shutdowns for maintenance. In 2018, disruption in global recycling markets led to major changes in the acceptable specifications for recyclable material. In order to find a buyer for the recyclables we're separating, they must now be 99.5% free of contamination. It's a challenging standard to meet and requires that we add more labor in the sorting process. This is why we need the public's help to ensure that only the correct recyclable materials are placed in each of the recycling carts. The recyclables then make their way to a second screening area, which separates material into 3 size groups: materials between 6 and 12 inches, from 2 to 6 inches, and less than 2 inches. If it hasn't been crushed in transit, glass is now broken and is removed with the 2-inch and smaller materials. Small non-recyclable items fall out with the glass, needing further processing to remove contaminants. The next step in the process is to separate material by density in one of 2 knee-hot single drum separators. These machines use powerful air currents to separate lighter materials, such as paper and plastic containers, from heavier materials like metal cans, and send them to separate conveyor belts. After air separation, recyclables flow onto a steeply sloped polishing screen where material is separated by shape. The polishing screen spins rapidly, creating friction. 2-dimensional materials like paper flow up and over the top of the screens onto a conveyor where an optical sorter is positioned to remove plastic bags that would contaminate the paper stream. 3-dimensional objects like bottles and cans bounce down the screens and exit at the bottom onto a different conveyor. Fines or non-recyclable residue like dirt fall through the screens onto a residue conveyor. From here, the paper stream flows past the last sorting stations before being stored in large bunkers. The container stream advances through a series of optical sorters, which use reflected infrared light to identify the type of plastic resin each container is made of, so it can be separated by type. As each plastic resin is recognized, a blast of air pushes it out of the stream and onto its own conveyor, all in less than a second. Meanwhile, metal containers are removed as they make their way through a series of strong magnets, which capture ferrous metals like steel cans. Next, aluminum cans are removed as they pass through an eddy current separator, where a series of magnets spinning at 2400 RPM create an electrical current which repels aluminum. This current shoots aluminum cans in one direction, while other metal containers continue along the conveyor. Sorting staff are positioned along the conveyors to pull contaminants and to capture any recyclables that the sorting system may have missed. The non-recyclable residual material flows out of the building to a waiting transfer trailer, which hauls it to the landfill for final disposal. At this point, all of the various separation processes are complete. Mixed paper, steel cans, cardboard, aluminum, and number 1, number 2, and number 5 plastics slowly fill large bunkers under the sorting platforms. Once a storage bunker is full, a door opens and the material flows down a final conveyor to the baler. The last step in the process is to densify the recyclables in this powerful baler. Here, the individual commodities are turned into heavy, dense cubes and then stored for shipment. A single bale of mixed paper or steel can weigh 2,000 pounds, while a bale of plastic or aluminum weighs 1,000 pounds. The bales are then loaded onto a truck to make their way to a final destination. That might be on a container ship to Asia for cardboard and mixed paper, or to a domestic buyer on the East Coast for plastic bottles. The final chapter of this story can only be written with your help. Doing your best to reduce, reuse, recycle, and buying products made with recycled content helps close the loop, which in turn helps the district fulfill its mission to turn waste into resources.